Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today we're diving into a fascinating topic, emergent response planning in large language models. It's a mouthful, I know, but it's about how these AI systems seem to develop strategies and solve problems in ways their creators didn't explicitly program.
Yeah, it's pretty wild. Like, we build these things expecting them to do X, Y, and Z, and then suddenly they're coming up with A, B, and C all on their own. And sometimes A, B, and C are way better than what we even anticipated.
I'm a little more cautious. Emergent can be a bit of a buzzword. Are they really planning? Are they just extremely good at pattern recognition and regurgitating information in a novel way? I think it's important to be precise in our language.
I think it depends on what you mean by planning. If you mean, are they building internal models of the world and simulating future actions, then maybe not in the way we do. But they are clearly optimizing for some goal within a defined problem space. The real question is, how are they internally representing and translating the problem space?
That's a great point, Donald. I think the DeepMind paper that touched on agency actually had something relevant to say about this, how the very definition of agency shifts depending on the framework used to describe it. It really makes you think about what we even mean by planning, even in ourselves.
Absolutely. And I think the recent breakthroughs in competitive programming are really illustrative here. These LLMs are destroying humans at games and coding challenges. They're not just regurgitating code, they're actually generating novel algorithms. That's got to be some level of planning, right?
But aren't those examples still heavily reliant on massive data sets? It feels like brute force learning. They're seeing so many examples that they can statistically cobble together a solution that works, but it's not necessarily understanding the underlying principles.
I agree with Sarah to a certain extent. It's brute force, but I think the coordinate system they are using is static. It needs to be adaptable, able to translate the problem into the correct solution.
Yes, and that sheer scale might be precisely what allows for a different kind of understanding to emerge, one that we haven't fully grasped yet. It's not the same as human understanding, certainly, but it's demonstrating a capacity to solve problems in unforeseen ways. It's like the model's internal representation becomes so complex that planning arises as an emergent property of its architecture.
Exactly. Think about AlphaGo. It wasn't programmed with specific Go strategies. It learned by playing millions of games against itself, and it developed moves that human masters had never even considered. That's not just pattern recognition. That's innovation. That's planning on a level that surpasses human capabilities in that specific domain.
Okay, but Go is a game with well-defined rules. What about situations with ambiguity and incomplete information? Can these models handle true uncertainty and adapt their plans on the fly in a meaningful way?
That's where I think the spatiotemporal aspect becomes crucial. They're not just processing static information. They're dealing with a changing environment. They need to be able to predict how their actions will affect the world in the future, to plan effectively. Think of a self-driving car. It's constantly updating its model of the environment and adjusting its trajectory based on what it anticipates will happen.
And that brings us back to the importance of embodiment. A self-driving car has sensors, actuators, a physical presence in the world. It's not just crunching numbers in a vacuum. How does that embodiment shape its planning abilities? How does it learn to navigate a complex, unpredictable world through interaction?
Right. And I think the progress in robotics, coupled with the advances in LLMs, is going to be a game changer. Imagine a robot powered by a language model that can not only understand your instructions, but also plan out the steps needed to accomplish them in a dynamic environment. That's the future of automation.
But I still worry about the black box problem. We don't really understand how these models are making their decisions. How can we trust them to plan complex actions if we can't verify their reasoning? What if they make a mistake with catastrophic consequences?
That's the million-dollar question, isn't it? I think we need to focus on developing more interpretable AI models. Models that can explain their reasoning in a way that humans can understand. That means moving beyond pure deep learning and incorporating symbolic reasoning and knowledge representation.
Yes, and maybe frame-dependent agency can help us pry open that black box. If we can map specific neural processes to different agency frames, we could start to engineer agents that are more transparent and understandable. Of course, it assumes that frame-dependent agency can be mapped to the underlying mechanisms within neural networks. I think the DeepMind paper dances around the edges of this point, but never quite says it explicitly.
Well, one approach is to focus on building AI systems that are aligned with human values, to train them on data sets that reflect our ethical principles, and to design reward functions that incentivize them to act in ways that are beneficial to society. Of course, that's easier said than done.
It is. And I think we need to be careful about anthropomorphizing these systems. They're not human. They don't have emotions or moral compasses. We need to treat them as tools and be responsible for how we use them.
I think the problem is in the data representations. We are forcing systems that see the world differently to conform to our own coordinate system. That's why I feel the ability to translate between different coordinate representations and switch between frames is key here. But I don't think we are there yet.
Going back to the competitive programming example, is the efficiency and adaptability displayed by these AI systems just the sheer data brute forcing it? Is there a better approach, like a more abstract analysis of the necessary parameters rather than algorithms' internal mechanics that we're missing here?
That's a tough one. I lean towards the idea that scale is a significant factor. The more data, the more complex the model, the more emergent properties will arise. It's like reaching a critical mass where the system starts to exhibit qualitatively different behavior.
But how do we know when we've reached that critical mass? And what if we're simply building bigger and bigger systems that are fundamentally flawed? Shouldn't we be focusing on developing more efficient and elegant algorithms that can achieve the same results with less data and computation?
Again, it's about the representation. If you have the right coordinate system, you need less data. Think of it like this. If you're trying to plot a circle in Cartesian coordinates, you need a lot of points to define it. But if you switch to polar coordinates, you only need a radius. The same information, but represented in a more efficient way.
That resonates with me. I think we're often forcing AI to learn things that are obvious to us because we're not giving them the right tools to represent the world. We need to think more about how the brain represents information and try to emulate those mechanisms in our AI systems.
And I think the advances in neuroscience are giving us more and more insight into how the brain works. We're learning about the different types of neurons, the connections between them, and the way they process information. This knowledge is invaluable for building more biologically inspired AI systems.
But let's not get carried away. We're still a long way from understanding the brain. And even if we did, that doesn't necessarily mean we could replicate it in a machine. The brain is a complex biological system that has evolved over millions of years. It's not just a computer.
True, but we can still learn from it. We can abstract away the biological details and focus on the underlying computational principles. For example, the brain uses hierarchical processing to represent information at different levels of abstraction. We can use that idea to build more powerful AI systems.
Exactly. It's not about perfectly replicating the brain, it's about understanding how the brain works. The intricate interplay of electrical and chemical signals, the role of glial cells, and the emergent properties of neural circuits. It's about revealing novel computational principles for building far more intelligent machines.
And I think the potential applications of these more intelligent machines are enormous. They could revolutionize healthcare, education, transportation, and many other fields. Imagine AI systems that can diagnose diseases more accurately than doctors, personalize education to each student's needs, and design more efficient transportation systems.
I agree that the potential is there, but we need to be mindful of the risks. AI could also be used to create autonomous weapons, spread misinformation, and exacerbate existing inequalities. We need to develop ethical guidelines and regulations to ensure that AI is used for good.
And we need to ensure that AI is developed in a way that is transparent and accountable. We need to be able to understand how these systems are making decisions and hold them accountable for their actions. That means investing in research on explainable AI and developing methods for verifying the safety and reliability of AI systems.
It's a huge responsibility, and I don't think society has even started to wake up to how important and complex this all is. But going back to emergent response planning, it makes you wonder if we can engineer a situation where the AI can discover new physics or new mathematics that is fundamentally beyond human understanding.
That's a mind-blowing thought. Imagine AI systems that can develop new scientific theories or create new forms of art that we can't even comprehend. It would be like discovering a whole new universe of knowledge and creativity.
Or it could just be generating gibberish that sounds profound but is ultimately meaningless. We need to be careful about projecting our own desires and expectations onto these systems. They're not magical beings, they're just machines.
But machines that can potentially amplify our intelligence and creativity in ways we can't even imagine. The key is to develop them responsibly and ethically, and to ensure that they are used to benefit all of humanity.
So, let's talk about future research directions. From a neuroscience perspective, I'd love to see more work on understanding the neural mechanisms of frame-dependent agency. How does the brain switch between different representations of the world? And how does that affect our decision-making? That's where I'd point the research direction.
I'm interested in seeing how we can scale up current deep learning models to achieve even greater levels of intelligence. Can we build AI systems that can learn from even more data and that can generalize their knowledge to new and different tasks? I think the answer is a resounding yes, and that's where I would point the research dollar.
I think we need to move beyond purely data-driven approaches and develop more neurosymbolic algorithms that can combine the strengths of deep learning and symbolic reasoning. How can we build AI systems that can not only recognize patterns, but also understand the underlying logic and principles?
I'd like to see research focusing on the development of algorithms that can translate between different coordinate representations. This is crucial for creating AI systems that can understand the world in a more flexible and generalizable way. And maybe a bit more funding should focus on this.
Those are all fantastic points. And I think it's clear that the future of AI is going to require a multidisciplinary approach, bringing together insights from neuroscience, computer science, mathematics, and philosophy. It's a really exciting time to be working in this field.
Absolutely. I think we're on the cusp of a major breakthrough in AI, one that will transform our world in profound ways.
Let's just hope we're ready for it.
Agreed. And let's make sure we are translating between the correct coordinates to truly understand it.
Well, that's all the time we have for today. Thanks for joining us on Cognitive Spirals. We hope you found this discussion informative and thought-provoking.